Hello everyone, welcome to the Unhandled Exception podcast. I'm Dan Clark and this is episode number 52. And today I'm joined by Steve Gordon, who was on the show right near the very beginning, back in episode 3, in which we didn't actually really have a topic, we just geeked out on various things. But today we are going to be talking about Elasticsearch, because he now works at Elasticsearch. So welcome to the show, Steve. Great having you on again.
Yeah, thanks, Dan. Great to be back. I can't believe how long ago that previous recording was, actually, when I looked back.
It's like 50 episodes ago, which doesn't sound much, but actually it was quite a few years ago. So.
Yeah, it's impressive to keep the podcast going. So I'm a regular listener. I enjoy the stuff you're putting out.
Oh, that's good to hear. But yeah, I think the editing is the bit that takes the time. Especially now I've started this YouTube thing. It's like we were talking before recording about finding time for stuff and lots of juggling, but I'm enjoying doing it, so it's good fun. I get to speak to lots of different people.
Yeah, that's the nice thing. It's getting different opinions, different ideas. I actually, one of the episodes you did on verify.net like quite a while back, and I've been using Verify now in a lot of the Elasticsearch tests that we do in terms of verifying the JSON output we're producing. So it's always good to listen to these things to pick up tips like that.
Oh, nice. So that was off the back of the episode?
Yes, yeah. I think I'd heard of it at some point and then promptly forgotten about it. And then the podcast episode reminded me to actually take a proper look at it and use it for something that I was actually needed to solve.
Oh, that's amazing. I'll have to let Simon know.
Yeah, it's really easy to get started with. And yeah, thank you to him and to you for to drawing my attention back to it.
I'll include a link to that in the I nearly said description down below then because of the YouTube thing, the show notes. I've got two terms to remember now. I'll include a link in the show notes and also to the podcast episode as well for that one. So to give you a quick proper introduction, and I'll let you fill in the blanks because I'm just reading your Twitter bio to be honest, but you're a Microsoft MVP, a Pluralsight author many times over, a senior engineer at Elasticsearch, which is what we're going to be talking about today, a blogger, a speaker, and also an AWS hero. I don't know what that is, but is that like the Microsoft MVP equivalent or something?
It is. I should take that off my profile, actually, because yeah, I've not been renewed on that one because I haven't really done anything with AWS in anger for a couple of years. So quite fairly, they sort of said, oh, yeah, we're not going to renew you this time around.
Fair enough.
So yeah, that one needs to come off the bio.
Cool. So apart from like, obviously you've got a job in Elasticsearch, what else have you been up to? It's been quite a while since we've had a catch up.
Yeah, I guess it's all a bit strange because we obviously gone through the pandemic years and lack of sort of meetups and things. Did a number of meetups and conferences remotely during that period. I must admit, I kind of got a bit of Zoom fatigue at some point and got a little bit worn out just trying to kind of attend those things and speak at those things. But yeah, now things are kind of starting to get back to normal. Been able to get back to some conferences in the last year or so. And yeah, it's nice to kind of finally be able to meet people again in person and talk about topics in person and actually get the kind of the proper feedback from people. You can actually see if the audience are understanding what you're saying and get questions afterwards. It's a lot more dynamic than typically the remote sessions tend to be.
Yeah, definitely. I remember seeing that you were doing lots of abroad talks and traveling the world and everything. Are you still doing that, or is it just dipping your toes back into in-person stuff?
Yeah, I did a few events sort of earlier part of last year. So I got to Techorama, Belgium, which was one I was quite keen to get to. And yeah, did a few events, did something in Berlin as well for We Are Developers. So yeah, got around a bit and got a few coming up. I'll be in Romania next month for the .NET conference over there. And then I think traveling in April to Sweden for DevSum over there. So yeah, there'll be more travel coming up. This time we're going to try and do a little bit with our baby as well. So we had a baby in the period since we last spoke on the podcast. So she's now, well, nearly 8 months. So we'll be seeing if she enjoys traveling and starting out with some European flights to test the waters on that one.
I was actually going to ask what's your secret? How are you doing that with kids? But if you take them with you, that's probably the secret then.
Yeah, that's it. Well, we thought we'd give it a try. I did NDC London in January and we didn't bother sort of trying to make that one work with all of us. But yeah, hopefully we can do Romania. We'll do a few days before the conference to kind of see the city over there. And then, yeah, same for Sweden as well. And in between, I think I've got Techorama Belgium again, but I think we'll just, that will just be a short trip for me on my own because I think we'll possibly overload on travel otherwise.
Are you getting down to DDD Bristol?
Unfortunately, I don't think I will be this year because it falls right after, I think, the Romanian conference, and we'll be back a bit tight, I think. So, yeah, I would have liked to get along to that one again because I really enjoy those. And I was just looking at DDD's Midlands has opened up the call for papers as well, I believe. And then that falls on the same date as another conference later in the year. So, unfortunately, I probably won't get to the DDD events this year much.
Oh, I missed that one. That's Jess White's one, isn't it?
Yeah, it is, yeah. Yeah, I meant to do it last year, and then I couldn't make it in the end. I was just going to go along as an attendee. I think something came up, and then hoping to do it this year. And again, it's sort of, that's the problem with these things. They tend to kind of be clustered together at similar times of the year. Most people avoid like the middle bit of summer, so they're kind of pre-summer and then post-summer events. And yeah, you just have to pick and choose which ones you're able to do each year.
Yeah, definitely, especially if you're traveling abroad. Right, so before we dig into Elasticsearch, I'm just going to quickly do this episode's listener mention. And this one goes to Danielle on Twitter. And she tweeted out about a previous episode where I was joined by Tanya Yenka to talk about application security. And she tweeted out, "Great episode, Dan. Completely agree. Psychological safety is important in teams. Thank you, Tanya, for sharing your journey as a speaker and for making Alice and Bob Learn Application Security available as an audiobook." So thank you, Danielle. And that was a really great episode. I really enjoyed chatting with Tanya. And if you want to get mentioned on the show, just send a tweet using hashtag unhandledexception. All feedback is greatly appreciated. And I'm Dracan on Twitter, which is DRACAN. I'm also on Mastodon, but that's much longer, so I won't read that out. That'll be on the website or something. And lastly, a quick reminder that this podcast is sponsored by Everstack, which is my own company providing software development and consultation services. For more information, visit everstack.com. Right, so Elasticsearch. I guess I can probably safely assume that most of the listeners have heard of Elasticsearch, but let's assume that some listeners haven't. What's the kind of elevator pitch for Elasticsearch?
I guess the short summary is it's a free and open search and analytics engine, ultimately. So a lot of people use it for storing data that they want to search over in some way, whether that be full text search or sort of more specific kind of range type searches across data. But full text search in particular is kind of where I guess the product began, built on top of Apache Lucene, which is another open source project. And it was first introduced around 2010, and it's kind of grown considerably since then in terms of capabilities and functionality. It's a fully distributed system, so if you're running it in your own environments, you'll be able to set up a number of nodes that all work together in a cluster to provide all of the functionality, and you can scale that to as big as your needs happen to be. Before joining Elastic, I was working at a company where we were using it for metrics, mainly metrics and aggregations over kind of time series type event data. And we were running at the time, when I left, I think we'd gotten up to about a 40 node cluster. So it's quite large, beefy AWS VMs. And I thought at the time that we were probably kind of like quite big. But since joining Elastic, I've learned that actually there's people that are storing huge amounts of data and running far larger clusters than we were managing.
So is a cluster or a node in a cluster, is that about compute, about storage, or is it both?
It's both today, yeah. So you can configure the nodes to have different roles. So by default, most nodes will just sort of start up with the capabilities for kind of all the standard functionality. As you tend to mature into larger cluster sizes where you have a greater understanding of where your load is, then you can kind of tune the system a little bit. So some systems are predominantly going to be ingest heavy, where most of the workload is kind of ingestion and transforming data and storing it, and maybe a bit lighter on their search usage. Or other organizations might be entirely the other way, and they might not have a huge amount of data that they're storing, but they do have a large number of searches over that data. So by configuring different roles on those nodes, you can define nodes that are, say, just coordinating nodes that are handling kind of the search piece, which is kind of basically pushing out the search to all of the nodes that might hold the data for that particular search, gathering that data back and then presenting the end search results to the caller. But also you can have nodes that are specifically geared around being kind of data nodes for storing the actual data. And we also, as people sort of mature in their journey, we have more specific node types for managing kind of data lifecycle management through different types of nodes as well. So that's typically where you have data that's kind of, as it ages, it becomes less important. So the typical sort of canonical example is log data. Most people want to store their log data for a long period of time in case they have, regulatory needs or they need to go back in time. But most often the data that's, past a week or two old, most people aren't necessarily searching over that in real time and expecting very quick responses. Those sort of pieces of data kind of typically just get searched occasionally. And so you can move your data through nodes, what we call hot nodes, to warm nodes, to cold nodes, and eventually to frozen, which is basically a way of sort of moving that compute cost down. So you can put that onto sort of cheaper hardware with the capacity you need to store the actual data, but not necessarily the full CPU power to support searching as very quickly on there as your data matures, basically.
That makes sense. So with obviously you mentioned metrics and logs there, which kind of probably answers this next question. But where you initially started saying that it's like searches and analytics, for that kind of stuff, do you quite often see Elasticsearch as being the primary source of data? Or do you I'm thinking that sometimes you might have a main database and then you would have a reporting database for searching or for analytics, which is like a replica or copy that's been transformed. Do you see different patterns around that, whether Elasticsearch has been used as the primary data store or a copy up from somewhere else?
Yeah, so we definitely do. And it's sort of entirely up to your use case. So I guess the standard example for people that we could sort of go with is maybe if you were running like a blog website that was kind of server-side rendered, so it has a database behind the scenes to store all of the data. For that, if you wanted to enable search across it, what you might do is basically take a copy of some of the relevant portions of the data that's there that you would expect people to be searching over. So you might just save the actual title and the content text, but you wouldn't necessarily need all of the metadata about the post to be searchable. And so in that scenario, it's very reasonable that you'd basically just have a duplicate copy of the data existing in two different data stores, your potentially your MySQL or SQL Server database, which is actually running the blog itself, and then the data store in Elasticsearch, which is responsible for performing the searches. But you can, if you want to, use it as a primary data store. So again, going back to the example I had previously, when we were building that metric system, that was entirely stored in Elasticsearch. So we were basically firing messages through AWS, through the queuing service, storing them into Elasticsearch, and that's where all of the storage occurred and where all the sort of usage of that data occurred. For that, we didn't need another database with standard sort of SQL-like querying. We just needed to be able to do kind of searching and aggregating over that data directly in Elasticsearch. That said, we also backed up the data to S3 and things like that as well, just so we had copies. If you are using it as a sole data store, then obviously you have maybe a few additional considerations around making sure that data's secure and you have backups. As I say, Elasticsearch is distributed in design, so you can automatically have it store replica copies of data across different nodes, so that if one node fails, you've still got a working system. And then the other piece of the puzzle really is performing snapshots of your data so that you can actually back up what's in your indices. And if you need to, if you lost the entire system or a big portion of your system, you could get that data back at a later time.
It seems very, very flexible with lots of different options. I know so I've not used Elasticsearch in production properly. I did play around with the Elk stack a long time ago, and I believe that's now called Elastic Stack, is it? Has that been renamed?
That's right. Yep. Yeah, so Elk is kind of the original name for it, which stood for Elasticsearch, Logstash, and Kibana, which are the kind of the three, I guess, main components that most people will come across when they're working with Elasticsearch directly. So Elasticsearch is your data store. Kibana is the UI for working with and managing Elasticsearch. So you can perform all of the kind of common operations to configure your clusters and kind of check on the health of those, as well as viewing your data and potentially building up dashboards against that data as well. So a lot of people might use that if they've got, logs flowing in, they might build dashboards over that log data or views over the data that they want to kind of be able to quickly search across. Maybe they, have saved views for errors that they can quickly go in and check in and see if there's errors being recorded by whatever systems are logging there. And then the Logstash part is about kind of getting data in. So for common scenarios where you might be wanting to record logs from servers or application log files or things like IIS log files, those kind of things, Logstash is one of the technologies that we have for kind of basically scraping those logs. You basically point it at a directory where your log files are going to be produced. As those come in, it can scrape those, parse through them, and then push that data into Elasticsearch. We've evolved that into kind of the Elastic Stack because there's now kind of additional components that if you start using the letters for each of them, you're going to have a really weird sounding acronym. So the Elasticsearch just sort of describes everything else that we have. So one of the things like Logstash, we've kind of evolved that into something that we now call Elastic Agent, which is a slightly more, I guess, structured way of being able to gather log data and monitoring data from disparate systems that you may have in your organization or disparate applications. So by enabling the agent, you install the agent on any servers that you're interested in monitoring. And then through a product called Fleet, which is basically the UI component, you can kind of centrally manage anything that's running the Elastic Agent and say, okay, I'd like to collect logs and start collecting logs from here and those kind of configuration things. So that kind of makes that sort of management story easier rather than having to configure Logstash on every device that you might want to collect log for. You can kind of, as long as you've got agent running, you can then centrally manage that through the Fleet product.
I see. So that's dealing with like logs, metrics, and traces, does it?
Yeah. So particularly logs and sort of application metrics, maybe like CPU measures and sort of memory consumption on devices, that kind of thing. We do have also Elastic Observability, which is kind of a wider solution that kind of covers things like application performance monitoring and application tracing. So we have agents that you can install into many of the different sort of applications you might be building, .NET, Python, Java, etc. You can install the APM agent into those and start collecting distributed traces across your system of anything that's happening within those as well.
Oh, nice. And can you actually render those traces as part of Kibana as well?
That's right, yeah. So we have an observability section within Kibana that you can enable if you're running the observability integrations. And once you do that, you can go into Kibana and start building dashboards against that data. And as you say, drilling down into traces, and particularly where you're doing like distributed tracing, where you may have microservices and they're all kind of starting to communicate with one another over HTTP. You can start to kind of trace those activities across the whole suite of services that happen to be sort of responsible for part of that operation.
Oh, very nice. Does this, because obviously OpenTelemetry is becoming a big standard now and a big thing, does that plug into this?
Yes, OpenTelemetry does work. I'm not sure as to which of those APM agents have like full support for it today. I know the .NET agent does have basically OpenTelemetry integrations, which for .NET is quite straightforward and nice because we obviously have like OpenTelemetry support built into .NET through the kind of the activity types and things that already existed and have kind of been modified and evolved now to basically work with sort of OpenTelemetry compatible spans and things like that. And so, yeah, it's quite nice that you can kind of just enable those features there and start collecting that data.
Yeah, that's really nice. One of those components I have actually recently started using is Logstash because so for one of my clients, we've got like a very old code base and a very new code base, which is probably quite common in some companies. The new one is using Kubernetes and Grafana and all that stuff, Prometheus and Loki for logs. But we couldn't get, the old code was very, very old .NET framework and very old packages and, the whole transitive dependency issues where we can't use the library because it's depending on something that we're already using an old version of. And then I hate the .NET framework days with dependency hell.
When you go back to those applications, you realize how good we have it today. I think, you can still run into those scenarios, but I think it's far less painful than it used to be. And anytime I dip into like older projects, I'm kind of reminded of where we've come from and how far we've improved things.
Oh, absolutely. Yeah, just dependency stuff. It's just a nightmare every time I go back. But now it just works. Most of the time. I don't want to say it always just works, but most of the time it does. So it's so much nicer. But so I couldn't actually, the stuff I wanted to put into the application to write to Loki, I couldn't actually do. So what I ended up doing is using a Serilog sync to write HTTP to a local Logstash running. So that took in like an HTTP input plugin and did a Loki output plugin for Logstash. And then I did a bit of a transformation in the middle, which was quite easy. It was just a bit of config file. And then so like on the same machine, the application itself is writing to Logstash, and then Logstash is buffering or doing whatever its thing is, and then sending it out to Loki. And that works really well. So it's kind of all these different Elasticsearch components. It shows how plug and play, and you can take the components you need, and really nice.
Yeah, exactly. Yeah, I mean, that kind of core stack that we described earlier, the kind of the out components are truly the kind of the core pieces, but then if we were talking about observability, and which is basically a kind of a solution of ours that we build on top of that. So we ourselves are consuming those parts of the stack to build those kind of services on top, which is what ultimately customers will be doing as well. We also have a whole security focused solution as well. That, again, similar kind of concept. You can configure agents onto your systems to collect the information that you need. And then the Elastic Security sort of integration in Kibana allows you to view that information and do threat detection and that kind of stuff as well. So it's all ultimately building on that core stack, and Elasticsearch is the data store for all of that.
Very nice, very nice. I should have actually read up what this was beforehand, but I keep on seeing something called Beats. Is that part of the stack?
Beats, yeah, it's a similar kind of idea. It's more of an older concept, I believe. It's not the area I'm directly involved with, but it's more of an older concept around sort of, again, collecting kind of metric information. So Beats, I think, have lots of different sub beats that you can set up to, you have file beats, or you have event beat and things. So you could have one that hooks into Windows events and things to be able to collect the information from those. So typically today, what people do is that might still be kind of working for you behind the scenes, but ultimately you would install Elastic Agent, and then through Fleet you configure the information that you want to collect, and if need be, then the agent can install and configure beats behind the scenes for you and start monitoring those particular things. So historically you kind of had to install all of that yourself, and that might mean multiple installations and configuration. But going through the agent and the Fleet UI, you can kind of centralize all of that into one place, which I think as soon as you start getting above a few servers, just definitely starts paying dividends.
So if I wanted to use Elasticsearch, and I know locally I can just use Docker and everything, but if I wanted to put this in production, what are the different hosting options I can choose? You mentioned VMs before. Is there an actual already hosted managed offering, or? Yeah,
so the historical way that most people would do it would be what we call self-managed, which is ultimately where you would either on your own hardware or on virtual machines, in the cloud services, you would actually have to install Elasticsearch on each of those VMs, configure them to be part of the same cluster, and ultimately once the networking's all kind of configured, they just start communicating and operating as a cluster. That scenario's okay. It works, but it does introduce, a level of management. So again, going back to my previous job, we had a systems team, and we had one person on that team in particular who was kind of the Elasticsearch expert and knew all of the sort of the intricacies of making sure that those servers could talk to one another, or if one of those VMs happened to crash for whatever reason, whether that would be something failing on the VM, or sometimes Amazon services just kind of disappear and all these kind of things. But they would be responsible for making sure that all of those things kind of were kept working. And so there is some overhead in that scenario where you have to have some people that are responsible for kind of maintaining the infrastructure, maintaining the the configuration of the cluster, that kind of thing. The much easier solution today is to look at Elastic Cloud, which, as the name suggests, is kind of a cloud-based solution. We basically offer that on the three major cloud providers today. So you can, when you spin up Elastic Cloud, you can choose where you want to host the service at both not only the cloud provider, but then obviously the regions and things. And then we'll go up, and behind the scenes, we can spin up all of the necessary infrastructure for you. So with cloud, you're basically taking away a lot of the complexity, I guess, of maintaining all of those individual VMs and the configuration yourself. You can just kind of basically through sliders determine, okay, well, I have this amount of data capacity that I'm going to need to store. So I need to obviously set my scaling to be appropriate for that. And then you can start choosing your different node types and things as well if you want to kind of start taking advantage maybe of those lower powered VMs for aged stale data. And so, yeah, all of that's kind of managed for you. And so Elastic Cloud's a really good way to get started if you just want to kind of play around with Elasticsearch. You mentioned the Docker image. That's still a really good solution for sort of local development. You can just spin up, an Elasticsearch single node Docker image on your machine. It's obviously not going to be fault tolerant or particularly powerful, but if you want to start doing kind of application development and local testing, that's still a good solution as well. And one of the things we started talking about is kind of what we're evolving into is providing an Elasticsearch serverless service as well. So if you go back and look at any of the recent sort of videos that Elastic have put out, you'll start sort of seeing some mentions of some of the ideas around this. But ultimately, this is basically taking the cloud concept a step further to the point where you don't even have to really think about this concept of nodes and sort of managing scaling of the data. You just really, as most consumers anyway, most people just want to be able to say, well, I want to store data and I want to search the data back. And I don't want to think too much about all of the stuff that I have to do to manage that and the decisions that you still have to make around, how you scale that when you get started. And so we'll be sort of, I guess there'll be more coming out about it, but I know we're working hard behind the scenes on kind of what the next iteration really of Elasticsearch as a cloud service will be, which will be this serverless offering.
Yeah, I can definitely see even the term cluster putting people off. It's like, well, for me, I get excited. It's like, oh, clusters, nodes, sorted, because I'm a big fan of Kubernetes and that kind of thing. But I think a lot of people might be looking to a new technology, see they've got to deal with clusters, nodes, sharding, all this kind of stuff. And it might be put off because there's, like that initial barrier to entry for learning, where, especially as you said, just to get started and have a play around, just to start dipping your toes in, if you can just go to like Elastic Cloud and spin something up and have a play, then that kind of like gets you started, I think.
That's it. I think for a vast number of people, they don't, they're not operating at the sort of volumes that mean that they need to, have all of this intrinsic knowledge about, as you say, sort of distributed systems and how you configure all of this stuff. They just have a requirement that's been handed to them as a developer. We want to provide full text search over some subset of our data. Can you go off and do that? And so having to think about, I need to understand, this concept of a cluster and all of these different node types, and then decide, how I'm going to shard my data across those to get the best performance and all of these kind of technical questions. Most people don't want to have to deal with that sort of complexity. So if you can go in and spin up a system and just say, okay, ultimately Elastic understand the intrinsics of all of that sort of behind the scenes background sort of configuration knowledge the best. So the goal is that we'll be able to kind of provide a service where we do all of the hard work for you, and you just kind of come in and just start pushing data in and running your searches across it, and we can scale it and manage how that data is stored in such a way that we can still provide the same kind of guarantees over resiliency and search times and those kind of things.
That's cool. Just going back to the Docker thing, a pattern that I quite often do for integration testing is spinning up stuff, like whether it's in this example Elasticsearch or SQL Server or RabbitMQ, whatever it is, and then run my integration tests against it, and then I can spin that back down. So I can do that, have that locally as I'm running my tests. I can have that in a CI/CD pipeline, so that can do the Docker compose up. And because it's just Docker compose up, run the tests against a real database, and then Docker compose down afterwards. It just means that I find my tests are, rather than doing lots and lots and lots of unit tests and mocking out everything else, it's actually calling a real database. So I get much more bang for buck for my tests because it's testing real stuff and I don't have to mock out all the things. So I find that's quite a nice pattern. So with software like this, I always like it when there's a Docker image equivalent that we can do that kind of thing with.
Yeah, it definitely makes life easier. I mean, I think, so going back to my days working with the AWS stuff, when I first started with it, there weren't very good options for running kind of essentially like local versions of S3 or SQS. That's come on a lot now. There's a product called Local Stack that we started using, and it just makes that whole, as you say, the whole developer experience a lot easier. And instead of writing these kind of mocked integration tests or ultimately what end up just being kind of some form of unit test, you can actually just have a test that actually does the real thing, make sure that the data's gone in, and you could search it back out just by as you say, spinning up as part of CI systems, just spinning up these temporary instances of, your data stores.
And we've kind of shifted over there to talk about code. And you and I are both .NET developers, and probably a lot of the listeners are .NET developers. And I believe when you started with Elasticsearch, was that to work on the .NET client for Elasticsearch?
That's right. Yeah. So I joined about 2.5 years ago now, and my primary role is as a kind of maintainer of the .NET client. So we have a team. It's not a huge team, but we have a team which we refer to as the language clients team, and we have people within that team that are each responsible for some of the kind of the most popular, programming languages today. So we have obviously JavaScript, Java, we have Go, and we have Python. So we have developers for each of those that are maintaining those projects, and we each basically produce these client libraries, which is ultimately going to be a NuGet package in the case of the .NET client that you can pull down to start working programmatically in your .NET applications against Elasticsearch. And that's gone for a bit of an iteration more recently. So we've kind of got what I'm kind of referring to as kind of the next generation of that client. That's been something I've been involved with for the last sort of year and a half or so, is kind of trying to restructure how we go about maintaining those clients to make it more sustainable, really, because Elasticsearch as a product has grown so dramatically since those early days. I think it's well over like 450, 500 endpoints now, HTTP endpoints for different functionality that it exposes. Each of those then have fairly complex objects models that they accept in terms of data in and data out. And so, our job is to try and make working with that as easy as possible in the languages. So, in case of .NET, you've got strong types that are classes that represent the requests and responses that the server can receive or send back to you, so that you can kind of just, create those instances of those requests, fire them into Elasticsearch. We'll handle routing that to the right endpoint for the functions that you're performing, and then giving you back an object that represents the response that you received.
Is there anything with the version, like for example, if I install the .NET Elasticsearch client and I'm looking at the NuGet version number of the Elasticsearch package, and I know that my self-managed instance of Elasticsearch is version X, is there any way of correlating that? Is there like a lookup or something somewhere I can know that version will work with this version, for example? Yeah,
so the way we've tended to do it, that does cause a little bit of a challenge, I guess, the fact that these are still different pieces of the puzzle that we're producing, is that we at least align the major version number of the clients to the version of the Elastic Stack, the Elasticsearch sort of instance that we are designing them for. So that's why it's quite interesting. We've just, as part of our work on this new client, it's a version 8 client in NuGet, but ultimately it's kind of a version 1. It's a new package name that we've just shipped from day one as version 8 to align, to say, to make it clear to users, actually, if you're using the version 8 server, this is the version 8 client that kind of aligns with that. Some of the language clients go a little bit further and actually align even down to the minor version, and maybe even the patch versions to a degree. So whenever Elastic does a release of the stack, we'll do a release of the client that aligns with that. Everything we do is generally kind of forwards compatible. So, the client will continue to work even if you upgrade the server to a later minor version of version 8, your code will continue to work. The only things you might be missing are any new properties that are available on those requests, or the ability to talk to new endpoints and things that are released. For those, you'd need to upgrade to the client that's kind of the same minor version that has those available in it. But version numbering is a real challenge, I think, because, in a sense, you want to be able to signal exactly what you're doing within the client library. So, if you need to introduce a breaking change for whatever reason, you'd ideally want to push that major version up. But by having to kind of pin to the same version of the stack, it's a little bit of a challenge there in terms of that. But that's kind of how we try to maintain a relatively easy compatibility story. That said, the V8 client that we have today is kind of feature limited. So we've basically fully started to re-engineer how we produce that client. And as a result, we had to kind of be a bit selective and say, we want to ship something. So we shipped what we had, and we kind of got working and tested as part of the V8 8.0 client. But it's not exactly fully aligned necessarily with all of the endpoints that are available. So we do also have the capability in the version 7 client to basically communicate to a V8 server. We have a mechanism on the clients and servers, which is where we negotiate the version of the API that we're working with. So the V7 client will say that it's a V7 client essentially by putting the correct vendor information into the accept header, and then the server can make sure that it handles the request and sends the response in the V7 format. This was introduced as part of kind of V7 and V8, and it really simplifies, I think, the migration story, because historically the problem people had with clients and servers is they want to upgrade the server because they want to get the latest features and they want to continue being supported and all of that. But that potentially means a rewrite of client applications, even if that's just bumping version numbers and checking things compile and running tests. There's some effort involved there. For more complex scenarios, that might even mean breaking changes, in those client releases, because again, historically, clients have to queue up those breaking changes until the next major version if they can. And so by introducing this compatibility mode, I think we've got to a much better place where you can say, well, we'll upgrade the server from 7 to 8. Our application will continue to keep running because it's sending the compatibility headers through to the server. And at the point you're ready to, once you've had the time to kind of do it, you can then upgrade your client applications and then push them out as well. Because otherwise you kind of get into this chicken and egg well, do we upgrade the client app first and then try and coordinate the release of that and the server? upgrade, it gets a bit complicated otherwise. So compatibility mode is hopefully going to make people's lives a lot easier there.
Yeah, that certainly makes sense and sounds like it makes your life a lot easier. So if a request doesn't have the compatibility accept header, does it assume version 6?
So the server will just assume its natural version if you don't send one. So if you just sent sort of application JSON as your accept header, you would get back the V8 server's version of that. The clients, the latest kind of 7x clients that we released, all do this automatically. So it's kind of built in that we would always put the V7 accept information on there so that you don't have to think about it. So as long as you're running the latest 7x client, you'll be able to communicate with an 8x server. Again, you'll be lacking any new APIs, any new options that are available on request, but you'll be able to at least keep existing applications communicating as they were. And then as and when you need those new features, you can start to upgrade them.
Yeah, I've always found that if you can upgrade to the latest whatever it is, then do as soon as possible, because otherwise when you do, you've then got like X major versions to upgrade in one go and it becomes a nightmare. So even like with the .NET stuff, I'm so glad that it's becoming so easy to just upgrade to the next version of .NET now. It's each year, and I would always try and just spend a bit of time to do as many apps as possible up to the next version as soon as possible, just so I'm not then lagging behind and have a big, massive headache to do at some point in the future.
Yeah, you're absolutely right. I mean, I think as soon as you start getting behind, then you start introducing challenges. So even for like Elasticsearch, a lot of people get into problems when they do start getting more than a version behind, because the migration story is typically that we'll try and make, or I believe the server team will try and make sure that the indices that you've created in, say, V7 still work and function once you upgrade that server to V8. But we can only provide that guarantee so far. And so when you maybe then go to V9, because we might change the structure of how those indices are kind of stored on disk and all of the kind of various data structures that we store to actually make search efficient, you'll find that you're in a situation where you might need to re-index that data using the new version of that sort of index format. So if you get too far behind, then you start kind of finding that you have to go through this kind of stage migration steps, and it can kind of be, a lot of work over a long period of time to kind of re-index all the data into kind of a secondary cluster that's running the new version. And once you've got all the data caught up, you kind of switch over. Whereas, as you say, if you kind of keep trying to update as soon as the features are available and the versions are available, then you can kind of reduce some of the pain. You're never gonna have a completely free experience, because there's going to be new features coming out, as I say, new data structures that we're storing for indices to function. So at some point you will need to sort of do that work with your data, but it's far less painful if you do it over stages rather than realizing you've fallen 4 versions behind and you have to figure out how you go through that migration strategy.
Yeah, just thinking back to my example of .NET, that's code, which is normally quite easy, but we're talking about data here, which is typically that's always the bane of upgrades and changes. So yeah, I can imagine that being even more important. So for this next question, you're not allowed to answer with versioning. Since you started Elasticsearch, what's the most challenging problem you've faced?
So probably for me, it's been this next generation of client and how we kind of design and architect it. So I've talked about this kind of like sustainability problem. If you assume that there's generally one developer per language client at the moment on the team, you can imagine that every time the hundreds of engineers that are working on the Elasticsearch server are working on new features and new endpoints and things, to try and keep feature parity with that and keep up with the pace of the development of the server product is sort of really unrealistic over time. When I joined, a lot of my job was just trying to keep up with each of those minor versions, which could introduce a bunch of new endpoints and features. For me to kind of model those by hand in C#, do the work to understand what the endpoints accepted as data structures, all of that took a fair bit of my time. And so, we realized, I think, that in order for the team to spend time on the more value add features, which is kind of more thinking about the higher level types that we can provide people to do kind of common operations and more efficiently, and to kind of focus on documentation and sort of the education piece as well. We needed to kind of take away some of the kind of manual labor work that was involved in keeping up. So we started work just before I joined, actually. The team started work on this thing that we called the Elasticsearch specification, which was We wanted to have a canonical model of all of the endpoints that Elasticsearch exposes, all of the data structures that they have, so all of the types of, request and response properties they can accept and things, so that we could then take that specification and use it to generate the clients. The challenge, obviously, first was getting the specification, because, as I say, there's like 400 endpoints. The documentation is a good starting point, but you start needing to look into the server code quite a bit to actually figure out, okay, well, this thing generally accepts a string, but sometimes it will also accept an integer because, reasons. And so we had to kind of reverse engineer a lot of the Java code from the server to kind of fully understand all of the actual JSON inputs and outputs that it accepted for each of the endpoints. So that work's been ongoing and has kind of got to a pretty mature place now. But then the other challenge was, okay, now we want to generate the clients using the specification. And this is kind of the reason that we've ended up with what we're referring to as the next generation of the .NET client, because there was literally no way that we could continue the V7 client by hand, handcrafted, hand-loved client in its exact same shape using automated tooling, because, everyone that's touched the code base over time has done their best to be consistent, but there are inconsistencies in how we model things, all of those kind of problems that you face. So the biggest challenge has been, taking that spec and producing a client, which we've achieved for the .NET client using Roslyn. So I don't know, some of the listeners maybe sort of have heard the word Roslyn before. Roslyn is the compiler for C# and VB. And one of the nice things about Roslyn is it's got a lot of APIs that allow you to hook into all parts of the compiler pipeline. And so the way we've done code generation is we've read the spec, we've parsed and understood that, and then we're converting it basically to the syntax tree that we want to generate for the C# code using the Roslyn APIs that we can then emit into files. So there's many ways you could do kind of code generation. You could just do it with like strings, and that's kind of the lowest tech approach. But by using Roslyn, we get a few more assurances about the actual structure of the code that we're producing. And there's lots of future things that I can see us doing as well in terms of kind of analyzing the existing project and then determining, what we're going to change and all of that kind of stuff. But that's been a big piece of work, much bigger than probably any of us expected it to be, which is why it took us a while to get that first version of the V8 client out, and why we had to make some compromises in terms of feature set. So we decided, well, there are still some complexities in code generation that we needed to solve. Let's ship what we can, what we know is working around the kind of core endpoints, the kind of CRUD stuff that you would do with a data store. And we can kind of focus on all of the problem areas and the nuances of the Elasticsearch specification as we come to them.
I do wonder where, like, with all this AI bubble we're hitting now with things like ChatGPT, how that can help us do this kind of problem where, obviously I'm simplifying it, but write me a client that matches this specification or something. Because obviously that's a very overly simplifist. I can't say that word. You know what I mean? And
yes,
simplification.
It's definitely a dream that would have made the work a lot easier. I think if you could just say, here's a spec, spit me out a fully working file. And obviously, across the C# landscape, there's lots of different solutions to this problem. There are generators from open API specs and things that people are using already, I think, to generate not necessarily clients, but at least the server portion of things. And of course, you could engineer that to generate client interfaces against those as well. A lot of the other SDKs that you see out there, like the Azure SDK, for example, I know they code generate a lot of that because, again, same problem. Azure is a massive landscape of services. And if you expect a team to kind of keep up with clients for that, with all of the features that you're exposing in the cloud, you do need a way to kind of automate that. So there's, again, you run into compromises, because as soon as you start code generating something, you have to kind of become very generalized in how you structure objects to represent the data. And the Elasticsearch specification definitely has some challenging areas. So we see quite a lot of polymorphism in the data that goes in and out of Elasticsearch. So for example, if you do a search against Elasticsearch, you send it a query, but we have like 50 different query types with kind of different subsets of information that you would attach to those, whether you want to search across, you're looking for just some terms in some data, or perhaps you're doing some more specific querying over like IP data that you have stored, and you want to do a sort of IP specific querying or date specific querying. And so each of those search queries is its own large data structure that we have to be able to, model, and we have to have ways of representing that in C# objects, either as kind of like, composable objects or sort of kind of wrapping container objects that kind of say, well, I can be one of many things, essentially kind of a big union of all the possible things that it can store. And it would be very helpful, I think, if we had discriminated unions in C#, I think, for some of those data structures. But we've had to kind of just model things in the best way that we can with the structures that we have today.
Yeah, to be honest, as you were saying all that, I was thinking just that. And I think we should get them in like C# 15, I think, maybe at some point.
Yeah, every year you sort of look at the, you see the issue. I think there's an ongoing sort of C# lang issue around discriminated unions or some kind of union concept for the language. And yeah, it sort of keeps getting pushed out and pushed out. I've heard Mads talk about this a few times, and I fully appreciate that they have to be very careful with C# features. When they introduce them, they have to make sure that they're designed, for all of the future scenarios they can possibly imagine. And so, I don't think we'll get it immediately, but maybe one day we can go back and basically, simplify all of the code we're doing to say, yeah, we'll just use the union feature.
Yeah. I think there's lots of reasons under the hood why it's like much more complicated than you'd actually think, but we'll have to move to F# instead.
Yeah, that's it. Yeah, I mean, it's certainly an option. And funnily enough, in sort of talking about that, that's kind of how we ended up modeling. So one of the challenges we had with the spec was, how should we define the spec for the Elasticsearch server? I know the team looked at like OpenAPI as the first choice because, yes, that describes server endpoints. OpenAPI has got a kind of constrained set of features that it's really good at, and it's good at like modeling endpoints and things. Where it fell down for us was all of these complex kind of polymorphic data structures and things and properties with all sorts of unions of data types that they can accept. Because the server's pretty lenient in some cases, and as I say, it'll accept like 1 of 4 possible values against a particular property. And the worst ones are the ones where they're coming back out from the server, and you get some of them are tagged, like you have like the identifier of the type in the actual object, but some of them, we kind of call those unions the real pain, where they don't even have that information. So the only way you can tell about the type of data is to first kind of traverse the JSON structure and find the fields that are unique to a particular object that we are then going to try and deserialize into in C#, so those can be fun.
So we touched a bit on AI before. Is there, because that's now becoming such a big thing, is there anything Elasticsearch are doing as part of their product with either ML or AI, that kind of thing?
Yeah, definitely. So Elasticsearch, one of the areas that's growing massively in terms of the endpoints and the capabilities is kind of the ML piece of the puzzle. So Elasticsearch can allow you to basically, load in any models that you might have and then run that over your data sets for you. So I know this is used quite heavily by like the security solution that we talked about earlier that's built on top of Elasticsearch uses this capability very heavily because like threat detection and things like that, that's typically not just a very simple search. You can sort of do some basic stuff that way. But if you're trying to look for like intruders that might be doing unusual things in a system, one of the best ways to do that is to have a machine learning model that over time is understanding the standard usage that it's seeing in all of the data you're collecting. And then as things start to deviate from that, then that's when you want to start alerting. If you're seeing an unusually high number of failed login attempts combined with some other scenario, then it might be able to flag that up and say, yeah, it looks like someone's, specifically, trying to get into your system here or attacking you at the moment. And this is where the risk is that you need to kind of go and mitigate. But yeah, there's the whole host of ML endpoints in there. It's not an area I've kind of worked with heavily myself. Like I've been working obviously on the endpoints and modeling them, but not necessarily understanding all of the terms that I'm seeing going across all of these different like model names and things and machine learning algorithms and stuff. But all of that's kind of in there now, and it's a big area of investment for people because, yeah, as you're starting to build up these large data sets, being able to either bring in pre-built models or build models on over the data that you have. It's an extremely powerful way to do certain operations within your business. There's the classic search story, but then there's also, these kind of automated stories where you want to sort of detect deviations from things or unusual activity, whether that's threats or, maybe just things that you want to be aware of. Maybe there's a sudden trend on a new product that you have in your product catalog, and you can start to see a combination of things that machine learning can kind of highlight to you in terms of, okay, this is an interesting thing that our business should be aware of and kind of go and try and take advantage of.
That's very cool. Very cool. Cool. So we're actually almost at the hour now. So was there anything else you wanted to bring up before we move on to dev tips?
No, I think we've done a good intro, I think, to Elasticsearch and the language clients there.
I'm definitely going to have a go away and have a play. As I said, I played quite a while ago, but it's been a while, so I might just do the whole Docker Compose up and have another play.
Yeah, I mean, I guess the only thing to add in that sort of vein really is that if there's people that are listening to this and that they're users of the client, definitely interested in getting, people's feedback. I know we've had some fair criticisms of the V8 clients, reduced API surface, and, we currently have some criticisms over lack of documentation, which, given that we've written a new client, we now need to go into kind of document how that works in the new form. Hearing that stuff and understanding, what features people are missing or what documentation is lacking is something that I'm always keen to kind of to hear. So yeah, whether that's a Twitter DM, the DMs are open on Twitter and I try and check them fairly often, or, whether it's dropping an issue on our GitHub repository for the .NET client, it's a good way to kind of let us know that, yeah, you're looking for something that we don't currently have, and we can have a discussion about, fixing that.
Yeah. Where I was joking before about ChatGPT is kind of documentation. I would definitely have a go at that, see what documentation that can write for you, because in the last episode I had Ian Cooper on and we're talking about his Brighter library, and we just got on to talking about ChatGPT at the end, and so we kind of actually got ChatGPT up and said, write me some code using Brighter, and it did it. It wrote loads, it did the handlers, it did the publishers, it was like, whoa, this is insane. And then we were talking about documentation, so we said, write me some documentation on this, and it just wrote pages of documentation in perfect English. It was absolutely insane.
Definitely, it might be worth checking that out.
I was going to say, if you need to do documentation, I would save yourself some time and give it a go, even if you just take what it comes and then use that as a starting point.
Well, I think if you've got a starting point, it's a really good way to go, because, as I say, we're generally, we're at the moment one developer per language client, so you can imagine there's, you've got some competing things that you want to be doing, whether it's, new features or improved features or documentation or content about the product. So there's never enough hours in the day to get it all done. But if we can offload some of that to AI, then I'm more happy to do so.
Yeah, definitely. I had a thing yesterday. I was pairing with a colleague, and what was it we were doing? Going back to our conversation before about how I do tests, where we doc compose them all up and then run the tests. We had a situation where there was a few services where I think one of them was ClamDB, which is a virus checking one. So one of our doc compose up services was ClamDB AV, and even though the container was initialized, it hadn't started and done its thing properly. So, and the tests were failing because it was just starting too fast. So we just wanted to write a bit of code like PowerShell or something that basically polled for both the Docker container to be up and running, but also do an actual TCP request to the container to make sure that it could talk to ClamAV natively. So I just typed literally that into ChatGPT, and it wrote a bunch of I said PowerShell, and it wrote a bunch of PowerShell, and it was like pretty decent as well. And then my colleague who I was pair programming with, well, not pair programming with, we were just in a call. He was the one that was doing it, and he prefers Bash. So we ended up saying, can you rewrite that in Bash? And it did. It just did it, and it's pretty much, it was like well commented, like used functions and everything, which was really nice. And it was like, no, seriously.
Yeah, it's impressive and scary and amazing all at the same time. I think, in a few years' time, we'll be looking for jobs, it seems.
Well, I don't know whether we will. I think developers that use it won't be. The developers that don't use it will be.
Yeah.
So it's kind of like we need to leverage this. Well, I say that it's kind of. I think the thing is we see a lot of things on YouTube and things where some people say this is going to take over our jobs, and some people saying ignore all these stories about this taking over our jobs. The thing is, we're looking at the current iteration. We're now in ChatGPT 4, but what's it going to be like in 5 years? I think that we're entering a massive change where everything's going to change very soon, because there's now this race on to come up with the best AI. And it could go both ways. That's why I kind of say it's both awesome and amazing and terrifying at the same time. It's amazing today, but terrifying. But what might it be in a few years' time? Yeah,
that's it. There's the unknown there. I mean, I think ultimately, hopefully, it gets to the point where it's kind of yet another tool. I mean, we've had various iterations of tooling over the years that have improved the experience of coding, and I guess maybe this could just be as you say, another one where you can use it to do the boilerplate stuff, and then the job of the developer is actually making that robust and finishing it off and verifying it and augmenting it with the specifics, but maybe avoiding some of the crud work. And it'd be great if you could just say, here's an API documentation or API specification for something. Go and produce me the stub, at least, of all of the types that this would be needed in a strongly typed language to represent this, because that's that's busy work really most of the time, modeling those kind of types. You want to be working on the more complex problems that go alongside those.
Yeah, exactly. Yeah, I kind of suspect from what I've seen so far, it's not just another tool, and it's going to be much bigger paradigm shift than that. But I don't know. Who knows what's coming? But yeah, it is quite insane what the things we're seeing, even like with the image and video generation stuff that's now coming out. It's absolutely insane. Anyway, we should probably do dev tips. Would you like to go first?
Yeah. So the one that I picked out for this show, I hope I didn't talk about it on the previous show. I should have checked, but I'm pretty sure I didn't. Is the GitHub CLI, which for people that haven't sort of seen it or been aware of it, is just a CLI tool that you can install, and from there you can issue all sorts of commands over to GitHub once you authenticate to it. And I use it quite heavily, not for anything particularly complex, but the biggest use for me is actually just pushing up pull requests. So, it's very easy with the CLI to just kind of, I ultimately just have a file with a one-line script that I copy every time and modify, which allows me to, push up a PR with a particular title and message and a set of labels that I want, because for the .NET Client repository we label everything, and we maybe have labels to backport it to previous versions and all of this kind of stuff. And if I have to do that through the UI, it's a bunch of clicking and messing around. So yeah, just running the GitHub CLI and just doing a GH create PR basically in there has been a massive time saver, and I think it's quite useful. And I say you could do a lot more with it, and you could automate a lot of stuff with it if you needed to, but just the process for me of everything I develop is in a branch, do my development work against that feature or that bug issue, do my local testing, everything else, commit it, and then basically just run this to push up to the main repository, open the PR, and then at least that can start the CI process running. And later on I can go in if I need to and tweak the labels and things. But for the most part, it saves me a chunk of time each day.
Yeah, it is very nice. I think I'm trying to remember what your dev tip was last time. I think it was about learning, I think.
It might have been. It sounds like something I'd talk about.
Yeah, the one thing I like about the GitHub CLI is, one thing I do quite often is, I've got it as an alias, so I'm trying to remember what the full thing is, but I think it's just GH run watch. But basically, if you've done a git push and a build's going, that will show you the progress of your building progress in your terminal.
Yeah.
So that's really nice.
Yeah, I think it's just the ability to avoid context switching, isn't it? Where you can, and if you're already in a terminal doing your Git commands and running integration tests and things, it's nice not to have to leave that environment too often. I can kind of just tab up through my previous commands and modify a push and a pull request open on there. And as you say, being able to do things like just checking status of stuff without again dipping out to another browser window and navigating away to something is quite powerful.
Yeah, that's where I use a lot with the Control R shortcut, where it's done the reverse history search. So if you've done it at some point in the past, you can do Control R and type a subset of a command you've written in the past. You can't remember the parameters, but then because it finds it quite quickly, and then you can Control R through them. Yeah, that saves an awful lot of time. So my dev tip is a library called Flurl, and I know you've actually blogged quite a bit on HTTP client and all that kind of thing in C#. So this is kind of it does the same job as, and it's probably, I'm sure it was using that under the hood, but it's for that kind of stuff where you actually want to send outbound HTTP REST requests. It's a very nice fluent syntax, but one super powerful, and this is going back to what we were saying before about tests, is it just makes testing so much easier. So with HTTP client, well, how do we mock this in our test if we've got some code calling HTTP client? It's a bit of a pain. But if you're using Flurl in your main code, then in your tests, you can just new up a new instance of, they've got it's called HTTP test class, which is disposable, so it uses the using pattern. And if within that using scope, you can basically override what the outbound requests are. You can do verify, so you can assert that a request was called. So it'll basically take over what the Flurl in your main code is doing, and you can just basically mock different outgoing requests. And then just everything you would do with mocking, you can do with this. But then it just means that you can test all of your code, and that's shifting the bit you're mocking outside of your code to the HTTP bit part. And yeah, it's just really, really nice. The syntax is nice anyway, even if you take away the testing from the equation. It's got a nice fluent syntax with lots of different options. You can just chain the methods together with the different options. And it's just really nice. So I will include a link to that in the show notes. And I'm actually with my YouTube channel where I'm doing 15-minute Grok talks on this kind of thing. An upcoming one I'm going to do is on this, so I will shove that into the show notes when I do it.
Sounds good.
Cool. So before we wrap up, where's the best place for listeners to reach out to you if they've got any questions about Elasticsearch or anything else?
Yeah, so as I say, Twitter DMs are open, and I do my best to kind of keep up with those as best I can. If it's specific to the .NET client, then there's the .NET client repository. We tend to try and keep that more to feature requests, issues, and things. And then Elastic have a discuss forum as well that people can kind of go and ask questions on about any of the language clients. And many of our developers from our team are kind of checking those out as well and trying to get involved in those. But yeah, if it's just me you want to target for some reason, then I'll keep an eye on the Twitter DMs as well.
Awesome. I'll include a link to all like the social stuff and things in the show notes. So thank you so much for joining me again. I'm glad I didn't put you off too much the first time when you've come back on.
Yeah, thank you. Well, I'll have to come back again in the future and find something else to chat about.
Yes, definitely. I will take you up on that. So, and thank you everyone else for listening. And a quick reminder that this podcast is sponsored by Everstack, which is my own company providing software development and consultation services. For more information, visit everstack.com. And if you're enjoying the podcast, please do help me spread the word on social media. I normally use the hashtag #unhandledexception, and I can be found on Twitter @Drakan, and my DMs are open. And my blog, danclark.com, has links to all my social stuff too. And of course, we'll include links to all the things we've mentioned in the show notes, which can be found on unhandledexceptionpodcast.com.